Determine if the following is true or false in a combination. Order is not important. So now we'll be doing two kinds of selection processes where we will have some things and we have to select a few from those. So we could either have a combination scenario or we could have a permutation scenario. So in combination, the order of your selections does not matter. In permutation, the order matters. So let's give an example. Suppose from a class of 50 students, I have to select 3 students for a student organization that's already running, and so the 3 students that I'm selecting are just going to be regular members. So now it doesn't matter in which order I call the 3 students. What matters is which 3 students I'm selecting, because they're all going to have the same rank. They're all just regular members. So in that case, it will be a combination problem. It would be 50 combination 3, because I'm selecting 3 students from a class of 50. However, let's say that I announce that, okay, I still need 3 students for my student organization. And the first one I call will be the president. The second one I call will be the secretary. And the third one I call will be a regular member. So now in this case, it's not just which 3 I'm calling, it's also in which order I'm calling them, which matters. So this will be a permutation scenario. And there are always more possibilities in a permutation than in a combination, because like, let's consider this example that the 3 that I call in a permutation scenario, they themselves have a lots of possibilities among them, that which of the 3 will be president and which of the 3 will be secretary and which of the 3 will be regular members. Whereas in a combination problem, that combination of 3 students is just 1 point. So there are always more in permutations than in combinations, unless you're only selecting one. In that case, it doesn't matter whether you're talking permutation or combination, because there's no talk of order in just one selection. But in general, there are more things in permutation than there are in combination. So now let's go back, and we have true or false in a combination problem. Order is not important. True. Order doesn't matter in combination. Suppose 5 objects are to be chosen from 10 distinct objects with no repetition allowed. Which will be larger, the permutations or the combinations? Yeah, we just said permutations are always larger. The number of permutations will be larger since there are more ways to choose if different orderings are counted separately. Yeah. List all combinations of 3 objects, M, L, and N, taken 2 at a time. Okay, so M, L, and N, and you have to take 2 at a time. And you know, in combination, order does not matter. So that means that if you have ML, then you don't need the LM, because ML covers for the possibility that M and L are selected. So it looks like D, ML, MN, and LN, these are the 2 combinations that you can make out of these 3. So now we won't have C, because you're not allowed to repeat. And we won't have B, because in B, they're counting ML and LM, for example, as different points. But in combination, ML and LM are the same points, since order doesn't matter. So it's D. And we've just figured out that 3C2 means in how many ways you can select 2 out of 3 if you're using combination. And we have 1, 2, and 3 points. So we figured out 3C2 is 3 by actually doing it, but later on we will learn how to do it on calculator. Decide if the situation involves permutation, combination, or neither. The number of ways a 4-member committee can be chosen from 12 people. So now nothing is being mentioned about whether the order of these 4 people matter or not. So by default, if we are not told whether order matters or not, then by default we assume that order doesn't matter. So by default it's combination, unless there is something pointing out that order matters, and then it's permutation. So the default is combination. So this one will be combination.